You got it all right. It's not that it's necessarily real hard, but it is kind of a longer process. So we will not have a separate quiz over this because of where it fell. So you'll see a couple problems on the final over this, and probably a bonus too. All right, so the empirical formulas is the simplified formula, or the formula that has been reduced to the lowest terms. For ionic compounds, we always write them as empirical formulas. So it's more that you're talking about your covalent compounds where you have to reduce them. So an example of that would be glucose, which is C6H12O6. This one would be the molecular or true formula for glucose. But if you look at those subscripts, they can all be divided by 6. So if I did that, I would end up with CH2O. This would be my empirical or my reduced formula for glucose, and probably a lot of other sugars too. So this would be like the monomer of a sugar, and then putting them together would give you the molecular compounds. So you can figure out the empirical formula from either the percentage of each element that's present or the actual number of grams of each element that are present. And whichever information you're given, your calculations will be the same. And we'll do one of each. So what's given to you in the problem, that's really not going to change your process that you're going through as you do this. All right, so the first step that you do is you're going to take the grams of each or the percentage of each element and divide it by the atomic mass of that element. And at this point, you want to leave your results in at least about 4 sig figs, even though that may not be what you end up with. So when we take our atomic mass off the periodic table, just like we've done before, you're going to round 2 places past the decimal. So at this step, at the first step, when we're doing this process, we're trying to find out how many moles of each compound. So that's what we do when we take the mass of how much we have that of the element and divide it by its molar mass. So once you've done that, you're going to look at your results and you're going to select the smallest value and divide all values by that smallest one. So at this one, we're looking at the ratio of the elements to each other, which is then what we'll use as our subscripts. So hopefully if you do step number 2, your results will either be exactly or very close to a nice whole number, or a recognizable mixed number fraction. So something like 1.5, where if you multiplied it by 2, you would get a whole number of 3. So if you just have a close whole number right there, that's going to be your subscripts. It saves you a little bit of time. If you have a number fraction, obviously we can't have a subscript like a 1.5. So if you have a number fraction, you're going to have to do step 4. All right, so if the result in step 3 is a mixed number, you must multiply all values by some number to make it a whole number. And step number 4, you do not always have to do. And we'll, like I said, we'll do one of each of those also. That's supposed to say you do number 4 where you can't read it. That's supposed to say that you don't always have to do step 4. All right. And then our last step is we're going to take those whole numbers that we figured out and they become the subscripts for our elements. So just take the elements and list them in the order that they were given and apply the subscripts that you have figured out, and that will become your empirical formula. And for organic compounds, you may end up sometimes with some molecules that are really large, which would mean you would have very large subscripts. All right, so let's look at a problem for this one. Nicotine contains 74.0% carbon, 8.7% hydrogen, and 17.3% nitrogen. And we're going to try to find out what is its empirical formula. All right, so we have 3 elements that we're going to be looking at. So I'll just start with my carbon. If it's in percentage, we're going to assume that we have 100 grams of it. So 74% of 100 grams would give me 74 grams. So that's what I mean by whether it's given to you in percent or given to you in grams, you're going to work it the same. All right, for my hydrogen, I have 8.7 grams. And then for my nitrogen, I have 17.3 grams. So that's my 3 elements and how much. And now I'm going to divide each one by its own molar mass. So the molar mass for carbon is 12.01. And when I divide that top number divided by the bottom, and here's when you want to keep it at least 4 sig figs, I'm going to get, can't read my own writing here, 6.162. I'm going to do the same thing for my other elements. Hydrogen, 8.7 divided by 1.01 is going to give me 8.614. And nitrogen divided by 14.01 is going to give me 1.235. So that's how many moles I have of each element. So now I need to see their ratio or how they're related to each other. So I'm going to take my smallest number of those 3 and I'm going to divide everything by it. 1.235 and 1.235. Now this is where I'm trying to get my subscript. So it would be nice if we had nice whole numbers. So this one's going to give me a 1. For my carbon, 6.162 divided by the 1.235 gives me 4.989, which we're going to say is close enough to 5. Hydrogen, same thing. Top number divided by my bottom number gives me 6.975, which we'll say is close enough to 7. So I'm not going to have to do that extra step on these because they all came out to some nice whole numbers. So now that tells me what the subscripts are going to be for each one of my elements. I'm going to put them just back in the order they were given. So I'm going to start with my carbon, subscript of 5, hydrogen, subscript of 7, and nitrogen, subscript of 1, but we don't write a 1. So this would be left just like that. And that is my empirical formula for nicotine. Does anybody have any questions on those steps or any of those numbers? All right, then let's look at and talk about molecular formula, and then we'll come back and do another one of those on the back page. So molecular formula, as far as calculating, is definitely the easier of the two. So the molecular formula can either be the same as the empirical formula, or it's some whole number multiple of it. So to determine the molecular formula, you must know the compound's empirical formula, like you figured it out just like we did, or it's given to you. And you must know the molar mass of the whole compound, and that always has to be given. If we knew the formula of the compound to figure its molar mass, we wouldn't have to be doing all of that. The molar mass of the whole compound either is greater than or equal to the molar mass of the empirical. All right, so to get through this, you're going to calculate the mass of the empirical formula, which was either given to you or you found. You're going to divide the known molar mass of the whole molecule, excuse me, so that's this one, by the molar mass of just the empirical. And when we do that, it's going to give us a little n. So to get my n, I'm going to take the molar mass of my compound, and that has to be given to you in the problem, and divided by the molar mass of the empirical. Remember, your top number is either the largest number or they could be possibly be equal to each other, but your smaller number should never go on top. So once you've got this set up, then you're going to take that n that you figured out and you're going to use it to multiply by the subscripts of the empirical formula to get the subscripts for the molecular formula. So once I have figured out my little n, then I'm just going to take it and I'm going to do subscript times subscript to change those, and that'll get me to my molecular formula. So if you found out that n was equal to 1, then that's when you would know that they just both happen to be the same. All right, so let's look at one of those. It's not as bad when you actually work one out and have to see all those words. All right, I'm going to do it down here at the bottom of this. We had just figured out the empirical formula for nicotine up above. So we have our empirical formula was C5H7N. That's what we did earlier. The molar mass of nicotine is 162.1 grams per mole. That's the one that I said would have to be given to you. And now we're going to try to find out what the molecular formula is. All right, so our first thing we need to do is we need to figure out our little n. So our little n is always the molar mass of the whole compound. So that's the one that's given to you. 0.1. Divided by the molar mass of just the empirical. So you would have to calculate the molar mass of that. And when you did, it would be 81.13. So that's just what we've been doing. Take 5 carbon, 7 hydrogen, and 1 nitrogen. That's where my 81.3 comes from. So just looking at those two numbers, what can you tell that n is going to be? 162 divided by 81 is going to be what? A 2. 162 divided, it's going to be really close to 2. So that's my little n. So remember now I take my empirical and I apply my n. So that means I'm going to do subscript times subscript for each element. So that'll give me C. 5 times 2 would be 10. Hydrogen 14 and oxygen 2. And that would be my molecular or my true compound, my true formula for nicotine. So this top number has to be given to you here. You may have to calculate it. You may be going to have to calculate it, but that's the empirical. It should be the same or smaller. Does anybody have any questions on that particular one? Where any of those numbers came from? All right. Let's flip over and we'll just look at a couple more. All right, let's just look at example number 1. All right, so this one we're trying to find the empirical. And it says that we have carbon, hydrogen, oxygen, and nitrogen. So a little bit longer than the one that we did in the first page because we have now 4 elements. So I'm going to just kind of get organized. So my carbon, and once again, the other one was given in percent. This one's given in grams. It's going to work the same way. So I'm just going to put how much I have of each one. And then my hydrogen, 6.542. Oxygen, 44.8598. And nitrogen, 26.1682. All right, does anybody remember the first step? What do I divide all of those by? We're not, and that's usually what people reject because we're trying to get to the end of it, but we're not quite there yet. Before we divide by the smallest, remember they have to be divided by their own molar mass. Okay, so in other words, carbon would be 12.01, hydrogen 1.01, oxygen is 16, and nitrogen 14.01. Because at this step, the very first step, I'm trying to find out how many moles I have of each. And here is also when I want to keep it at least 4 sig figs. So 1.868, 6.477, 2.804, and I got another 1.868. All right, that's how many moles I have. So now we need the ratio. So now we're going to divide by our smallest number. We have a couple of 1.868, so we'll divide everything by that. So this is when I'm trying to get to my subscript. So it would be nice if these were all nice old numbers. Save me a little bit of work. So carbon and nitrogen are easy. Hydrogen, I actually got 3.5, and oxygen, I got 1.5. So I can have subscripts of 1.5 and 3.5, but that's easy. What can I multiply them by to get them to a whole number? 2. I have to do that for all of them. So even though the ones were good, you still have to do the same thing to all numbers. 2. So I got 2, 3, 7, and 2. Now I have my nice numbers. And I can put it back together to get my formula. So C2, H7, O3, and N2 would give me my empirical formula. Anybody have any questions on any of that one? So, I mean, that's about the longest that they get, 4 elements, and then having to do that little extra step. That's probably would be one of the longest ones you would see. All right, let's come down and look at just another molecular before y'all try one. A molecular that's not dependent on something else that you calculated. So this one says the molar mass of a compound is 181.50 grams per mole. So that's the molar mass of my whole compound. Remember, we're doing molar mass of the compound divided by molar mass of empirical. And then it says the empirical, this is my empirical formula. So to find my little n, I take molar mass of my whole compound, 181.50, and I divide it by the molar mass of just this compound. So I'd have to do that. 2 carbons, 1 hydrogen, and 1 chlorine would give me 60.48. So that comes from that one. All right, so 181.50 divided by 60.48 is going to be about what? About 3. Really close to 3. So that becomes my N. So I'm going to write all these steps out, although I realize at this point you probably don't need to actually do this. But remember, once I figured out my N, I apply it to my empirical and I do subscript times subscript. So that would give me C what? C6, H3, and Cl3. So that's kind of a molecular that's not dependent on something else that you found. So there'll probably be like one of those on the test. For a bonus, I'll probably do something harder that you have to figure out the empirical first, and then you have to figure out the molecular to just kind of set it up as a bonus. All right, does anybody have any questions on that one? All right, why don't y'all go back up to example 2 and see if y'all can do that one. We got some tin, some chlorine, and some iodine. See if you can get a molecular formula for that one. All right, anybody got something on that one? SNCL2 I2, that is correct on that one. Anybody have any questions on that one or want me to work through it? Good on it, all righty. All right, so you have some practice for that. Like I said, you'll also see a couple of problems on the semester test. So Monday we'll do the journal test and then I'll give you all the review to work on. And then the next day we'll play the review game, earn some extra points for the journal, for the, not the journal test, the semester test. And we'll have our Christmas break. I'm personally ready for it.